I'm Dr. Eli Kohlberg from Unlimited Robotics, and in this video I will talk about the structure of materials. Material is everything that occupies a volume in space. Material has measurements and weight. Materials can exist in three states: solid, like a table for example, liquid, like water, or gas, like steam. Every substance consists of particles that are called atoms. Element is any substance that cannot be decomposed into simpler substances by ordinary chemical processes. Elements are the fundamental materials which all metals are composed of. Each element consists of a specific amount of atoms. Examples of substances that are elements are hydrogen, oxygen, silver, gold, copper, iron, and aluminum. Atoms are the basic units of materials and they define the structure of elements. The term atom is derived from the Greek word for indivisible, since back then scientists thought that the atom is the smallest component exists in the universe and cannot be divided. Well, atom is the smallest amount of substance that still keeps its identity as a chemical element. But the atom is divided into two areas with even smaller particles: the nucleus and the area outside of the nucleus. The atom's mass is concentrated in its nucleus. The nucleus area contains two types of particles, proton and neutron, in a balanced state. The number of protons is equal to the number of neutrons in the nucleus. The number of electrons outside of the nucleus in a balanced atom is equal to the number of neutrons in the nucleus. The protons and neutrons has approximately the same mass, which is 1.67 multiplied by 10 to the power of minus 24 grams. It is called an atomic mass. The nucleus contains more than 99.9% of the atom mass. Typically, the nucleus is less than 1/10,000th the size of the atom. The neutron has no charge and the proton is positive charged. The protons has slightly less mass than the neutrons. The components of the nucleus stick together by means of strong force, which is one of the four basic forces in nature. This nuclear force overcomes the repulsive electronic force. Without this force, the protons would move away from each other. The nuclear force is much stronger than the electrostatic force that binds electrons to the nucleus. Protons are particles that are positive charged and are part of the nucleus. The number of protons in an atom is unique to a specific atom. For example, carbon atom has 6 protons, hydrogen atom has 1 proton, and oxygen atom has 8 protons in its nucleus. The number of protons designates the element's atomic number. The number of protons determines the chemical behavior of an element. The elements are arranged in a periodic table with ascending order of the atomic number. The electrical charge of a proton is positive and is marked with plus sign. Neutrons, as their name implies, are neutral charged. It means that they have no charge. The mass of a neutron is a bit heavier than the mass of a proton. Electrons exist out of the nucleus. They have a negative charge minus. Electrons move in a fixed elliptical orbit around the nucleus. Each electron occupies a specific orbit, sometimes it is called shell, that has a certain distance from the nucleus. Each orbit with a certain distance from the nucleus has a specific energy level, which means that electrons in a different orbits has different energy levels. Atom formation and physical principles allow chemists and physicists to predict the atom characteristics such as stability, boiling point, and conductivity. Each orbit with a certain distance from the nucleus has a specific energy level. The electrons are way smaller and the mass is 9.11 multiplied by 10 to the power of minus 28 grams. It means that the mass of an electron is about 1800 times less of the mass of the proton or neutron. This is the reason for ignoring the mass of electrons when specifying the atom mass based only on the mass of protons and neutrons. The electric charge of an electron is negative and is marked as a minus or E minus. The electron and the proton has a special feature that is called electric charge. The charge of an electron is minus 1.6 multiplied by 10 to the power of minus 19 Coulomb, which is designated by the letter C. The charge of a proton is positive plus 1.6 multiplied by 10 to the power of minus 19 Coulomb. For example, helium atom has 2 protons and 2 neutrons in its nucleus and 2 electrons in the external energy level. Following the figure below, which presents the structure of an helium atom, we can see that helium atom has 2 neutrons, 2 protons, and 2 electrons in the same shell or energy level. Following the figure that presents the structure of oxygen atom, which has 2 energy levels with 6 electrons in the external energy level. Charge is measured in Coulomb and designated by the letter C. These are the units. The charge of an electron is minus 1.6 multiplied by 10 to the power of minus 19 Coulomb. This is the oxygen atom. We can see the oxygen atom has 8 protons, 8 neutrons, and 8 electrons in 2 different energy levels or 2 different shells. The nucleus constitutes most of the atom's mass. Atomic mass, in abbreviation AMU, is derived by the addition of the number of protons and neutrons. Atomic number is the number of electrons, which is equal to the number of protons. The outermost energy level, which is also called shell, of an atom is known as its valence shell. The electrons present in the outmost energy level of an atom are known as the valence electrons. Maximum allowed electrons in the valence shell is 8. Maximum 8 electrons are allowed in the valence shell, which is the outermost energy level. The valency of an element is defined as the combining capacity of its atom with atoms of other elements in order to acquire octet configuration, which means to have 8 electrons. If an atom's outmost shell is completely filled with 8 electrons, they are inert or least reactive and their combining capacity or valency is 0. Atoms having 8 electrons in the outermost shell is having octet configuration and are stable. If an atom's outermost shell is not completely filled, it is not stable. It will try to attain stability by losing, gaining, or sharing electrons with other atoms to attain octet configuration. The number of electrons lost, gained, or shared by an atom to attain octet configuration is the combining capacity or valency of the element. Now, a little quiz, try to answer it by yourself. Which particles exist in the atom's nucleus? Protons and neutrons, protons and electrons, neutrons and electrons, or protons only? Try to answer. Second question. Which subatomic particle has the smallest mass? Proton, electron, neutron, or nucleus? Try to answer. Next question. What gives the atom its mass? Protons and electrons, protons and neutrons in the nucleus, or neutrons? Next question. The number of protons is equal to atomic number, number of neutrons, number of electrons, number of energy levels. Right answer? Last question. If an atom has 6 protons, 7 neutrons, and 6 electrons, what is its charge? Positive, negative, neutral, or not possible to determine? Okay, this is the last question. Try to answer it. And that's it for now. Thank you all. See you in the next lecture.